Now let's talk about hardware Trojan taxonomy. Based on different criteria, the hardware Trojans can be categorized in many different ways. These criteria include: 1. The hardware Trojan will be inserted in the microchip supply chain, and more specifically, during the many stages of chip design, which stage or at which level of abstraction the hardware Trojan will be embedded. How the hardware Trojan will be triggered or activated, and what will the hardware Trojan do once it is activated, or what is the goal or payload of the hardware Trojan. Which system components or where the hardware Trojan will be inserted into, such as the processor, memory unit, or clock networks. Whether the hardware Trojan is functional or non-functional. In the case of non-functional, it is also called parametric hardware Trojan. Are the hardware Trojans big or small, tight or loose? Tight means that the hardware Trojan is clustered or centralized at one spot on the chip, and loose means that the hardware Trojans are distributed all over the chip. Does the insertion of the hardware Trojan require redesign of the layout or not? We will explain this hardware Trojan taxonomies in details with some hardware Trojan examples. The first one is the hardware Trojan taxonomy based on the IC supply chain that we have seen earlier. To refresh your memory, the green blocks we have seen here, they are generally considered to be trusted phases. The red blocks, they are untrusted phases. And the yellow block, they can be either trusted or untrusted. In the first system specification phase, we define the functionality of the system and its large building blocks. We also give the performance requirement for these components and their communication protocols. For example, the system has to be of certain size, the power consumption has to be lower than certain value, and there must be some timing or delay requirements between the modules that will be communicating with each other. Hardware Trojans can be embedded at this phase by deliberately change a module's functionality or the communication protocols among modules. Next, the design phase is in this supply chain is perhaps the most vulnerable stage for hardware Trojan insertion. This is because during this phase, third-party IPs, design tools, design libraries, and many other things that are out of the control of both the system user and a trusted design team will be involved in the design. We will give a more detailed categorization of hardware Trojans at this phase later. Once the chip design is completed, mask set will be made to fabricate wafers. In this phase, attackers can embed hardware Trojan into the mask or change the chemical compositions to do the damage on the system. For example, by increasing the electron migration in power supply or clock network, they can make the chip age faster. When the chip is assembled with other hardware components, extra wires can be added to leak information from a module or to control that module. Also, unshielded wires can leak information through the electromagnetic set channel. Finally, in the testing phase, not only system's functionality, but also its trustworthiness will be tested. Hardware Trojan can be inserted in this phase, so other hardware Trojans embedded earlier in the design phase will not be detected. This is a typical IC design flow, starting from the high-level system and architectural synthesis all the way down to physical design before chip fabrication. In each of these design phases, hardware Trojan can be embedded. For example, in the circuits that compute X squared we have seen last time, the valid input values to the system are from 0 to 9. A hardware Trojan, as we have shown, is inserted, so the circuit can also compute the square of 10 and 11 correctly. In that way, the system will authenticate attackers with the pairs of 10 and 100 or 11 and 121 as their username and password. This is a hardware Trojan inserted at the functional level, and it is done by adding 10 and 11 as valid input to the system. As another example, consider this block, which is controlled by an enable signal X. When X is equal to 1, the block will be disabled. When X equal to when X equal to 1, the block will be enabled. When X equal to 0, the block will be disabled. At gate level, a hardware Trojan can be easily inserted to control the usage of this block. For example, we can replace this control signal X by a 2-input AND gate. The attacker will set the hardware Trojan's trigger signal C to be 1, so the system will behave normally. When the attacker wants to disable this block, he can simply set the hardware Trojan trigger signal C to be 0 and to disable this entire functional block. This type of hardware Trojan is sometimes called killer switch because it can disable or kill a hardware component. Similarly, this can also be done with a 2-input OR gate. However, in this case, the building block will be disabled when X is set to be 1, and it will be enabled when X equals to 0. So in the normal case, we set D to be 0, so to let the system behave normally. And once we try to disable the system, we set D to be 1 to disable the block. At transistor level, there are also many ways to insert hardware Trojans. For instance, some physical parameters such as threshold voltage or transistor size can be changed to impact the delay of the logical gates, the power consumption of the logical units, or the aging process of the transistors. These timing or power features may leak information or facilitate side-channel attacks. At the physical design phase or the layout level, the physical parameters of the circuits, such as the dimensions or the locations of the circuit components, can be changed to embed hardware Trojans. These hardware Trojans are called parametric Trojans, and we'll discuss them later on. Finally, the design environment, particularly the CAD tools used during the design phases, cannot be trusted. Hardware Trojans might be inserted into the system through the use of these tools. Based on whether the hardware Trojan changes system's functionality or not, they can be considered as functional hardware Trojan or parametric hardware Trojan. Functional hardware Trojans are those that will change the system's functionalities. Examples include adding an extra functional unit, removing or modifying system's components. Parametric Trojans, on the other hand, normally do not change systems' functionalities. Instead, they try to reduce systems' reliability to increase the chance of performance failure. This can be done by changing the physical parameters of the system components, such as making the wires thinner or the transistors weaker, or modifying the power supply to cause certain parts of the system to age faster than expected. Hardware Trojans can be always on or triggered by some event or signals. The Trojans, such as those based on the modification of physical features of the transistors, wires, or other hardware components, they are always on. Hardware Trojans can also be triggered, and in most of these cases, triggered by rare event or signals. These triggers can be data collected by the sensors or logical units from the hardware components, such as registers or counters. The triggers can also come from either internally or externally from outside of the chip. Here are several examples. A time bomb, as its name suggests, will explode when a preset time expires. In hardware Trojan, this can be easily implemented with a counter or a finite state machine. When a counter reaches a preset value or the finite state machine reaches a certain state, the hardware Trojan will be activated. This is an internally triggered and logical triggered hardware Trojan. A temperature or other physical condition-based hardware Trojan can be activated when such physical conditions is met. For example, when the on-chip temperature reaches a certain degree, or when the supply voltage becomes lower than a given value, or when the outside humidity reaches certain levels. These kind of hardware Trojans are triggered by sensors and can be either internally or externally, depends on where the sensors are. Hardware Trojans can also be triggered by outside signals, such as user pushing a button, turning on or off of a switch, or when certain input values are entered into the system, maybe even wirelessly. These hardware Trojans are externally triggered. They can be either sensor-based or logical value-based. The payload is the action or the damage that a hardware Trojan will do once it is activated. We have mentioned from the very beginning there are three major types of damage or malicious purpose a hardware Trojan may have. First, it may try to change or control the functionality of the system. Examples include the killer switch we have mentioned earlier, the time bomb, and the simple fx equal to x squared example we showed last time. Second, a hardware Trojan may try to leak sensitive information. Normally, this is done through side channels such as the power network, the clock network, optical, thermal, or electrical magnetic emissions. Finally, some hardware Trojans may try to reduce circuit reliability or the lifetime of the system. These type of Trojans include parametric hardware Trojans or those Trojans that can activate applications or function units that will drain resource from the system to make system die earlier. Hardware Trojans can be embedded into many locations of the system. In the processor units, hardware Trojan can be hidden there to change or control the system's functionality. In memory structures, hardware Trojan can be embedded to alter or to change the memory's content, or simply to monitor memory activities and leak information. The I/O devices are the link between outside world and under the chip. So hardware Trojan can be embedded there to control, monitor, or modify data communication between the chip and outside. Power supply units, hardware Trojan can be embedded there to change the power or current supply to cause system failure or to leak information through the power side channel. And the clock grids is another position to hide hardware Trojan. Attacker can change the frequency to cause fault or failure, and to leak information through the timing side channels. Based on the physical features of hardware Trojans, the hardware Trojan can also be put into several different categories. So first, based on their size, we can have large or big hardware Trojans, such as sophisticated time bombs or powerful antennas embedded or hidden in the system trying to receive signals from outside. There can also be a lot of very small hardware Trojans, such as the killer switch we have seen earlier, just a simple 2-input gate, or some very small temperature sensors. Sometimes when hardware Trojans are embedded into the system, we need to redo the layout or placement and route. And the examples of this are including adding functional units, which are non-trivial ones, cannot fit into a small actual space on the layout. There are also hardware Trojans that does not need to change the layout. For example, the parametric hardware Trojans, or some very small hardware Trojans that can utilize the actual white space on the chip's layout. And finally, we have mentioned earlier, based on the distribution of the hardware Trojans, they can be either centralized or distributed. The centralized hardware Trojan, normally they are bigger. They can take a bigger space on one spot of the chip. And the distributed hardware Trojans, they're normally small, and then they are scattered all over the chip. Next time, we're going to talk about how we can detect different type of hardware Trojans.